Hello, welcome to PiPad Mathematics. This is Professor Lamb, and you're watching another video from Brainingcamp's Number Rods app, which is an app that utilizes the Cuisenaire rods, also known as integer rods or number rods or fraction rods. They're known by many different names, but they are a set of 10 rods that are of length 1 centimeter to 10 centimeter. Different colors, and then they show relationships between quantities. You can explore a number of things, and in this video we're going to explore the quantities that are greater than 1. So we're going to look at improper fractions. We're going to look at mixed numbers with this video. Now, like anything, when you're dealing with fractions, when you're dealing with any aspect of parts of a whole, we have to know what the whole is. We have to define what the whole is before we can do anything with fractions. So we have this rod over here, this orange rod, and we know it's of length 10 when we compare it to our white rod because it takes 10 of these. Well, we know if we measured it's going to be 1 cent, or it's going to be 10 centimeters. But if we take this and we establish it as our whole equals 1, then let us model something that is greater than that whole. We can model, let's say, this number here. So what does this number that I just created, what is that number when the orange rod equals 1? Well, we got to find out. Well, we obviously have values that are greater than 1 because we have more than one of these orange rods. Or if we were to line these up, they would be length greater than our orange rod by itself. So therefore, it's more than our whole. It's more than 1. Well, how much more than the 1 is it? Well, we have this is 1 and this is 1, so together they make 2. But what is this? What value does this dark green rod have? Well, we've done in other explorations this idea of breaking that dark green rod down into smaller pieces. We have our dark green rod, and when we lay it one next to the other, we notice that the value of that is greater than 1. Therefore, we can't just say one of them is a unit fraction of the whole, because you can't get a whole number of these dark green rods into our orange rod. Therefore, we have to break this dark green rod down into smaller pieces that we can fit into the whole. You can use the white rods, but I'm going to prefer to use the kind of the larger of the rods because that's going to establish a more simplified fraction at the end. Well, we have this red rod, we know goes into the goes into the orange rod 5 times. So this red rod equals 1/5 of our whole. And we can see that 3 of these red rods, and when I click them in, make up our dark green rod. So our dark green rod is going to equal 3/5. 3/5. When I write this, I have one whole, I have 2 wholes, so there's our whole number part, and then I have a fractional part which is 3/5. So 2 and 3/5. And that idea that I just said there, which is 2 and 3/5, is why we add the whole number to the fractional part when we do mixed numbers. Because it is the whole number parts, the wholes that we've made up, plus the fractional parts that make up the total that we have here. This, of course, is a mixed number relationship. Let's see if we can do it in an improper fraction relationship. We are dealing with fifths here. We broke the dark rod down into the red rods. So we need to do the same thing with our whole parts. We need to find out how many of these reds fit into the whole part of our number. Well, we know 5 reds go into an orange. So 10 are going to go into 2 oranges. So I have 10 reds. Let me write 10. So I'll have 10 rods there, and I'll have 3 red rods there. All total, we're going to have 13 reds, which are all fifths. So 13 fifths. And that's our whole number, 2 and 3/5. Where you have 2 wholes and then a fractional part. But when we break all that down into, in essence, equal parts, the red rod, the fifths, we have 13 fifths. This later on, not automatically, later on will be connected to the fact that we say 2 times 5, that's how we got our 10 here. We took our whole numbers times the number of these parts that fit into that whole part, these whole numbers. So 2 times 5 gives us our 10, and then we add going up, that's adding the fractional part here. So that is 2, the whole number, times the fifth, how many fifths fit in there, plus how many of those fifths you had to start off in your fractional part. That is our procedure of a whole number, 6 1/8, equals, we always multiply down and add up. So 6 times 8 is 48, plus 1 is 49/8. We have a nice procedure that gets us there, but if we only teach the procedure, students lose sight of the conceptual. Students must see the conceptual. They must understand where these things come from, or else they're going to be lost when they're trying to apply these concepts. You can't apply a concept if you don't know the concept. If you only teach the procedure, then you lose sight of what it actually means and where it comes from. And that was one example there. You can do many other examples. You can say, this is my whole. If that's my whole, then what does an orange equal? Well, the whole here, if that's 1, this is going to be 1/9 more. So that's 1 1/9. How do I know it's 1/9? Because of the white part being a part of the whole. Not the orange now. We redefine the whole as the blue. So this white is now 1/9 of our blue. So therefore the orange is going to be the whole plus that 1/9. Or 1 plus 1/9, 1 1/9, or 10/9. So exploration, there's many other examples that you can have and you can do with this app, but the idea is a teacher of mathematics needs to allow students to explore these concepts and build the understanding of mixed numbers, of improper fractions, and Cuisenaire rods can do just that, or number rods can do that. And this app and this technology allows it to be engaging, interactive, and if you just have paper cutouts on the desks and you're presenting it with this iPad app, that's fine. But if you have everybody having an iPad or some type of device and then you're projecting on the wall, that's great too. Either way, you need to get students engaged. You need to allow students to explore the old mathematics with the new technology. I thank you for watching. This is Professor Lamb, and you're watching PiPad Mathematics.